Welcome to tonight's video. We'll continue talking about limits. And so we talked at the end about indeterminate forms and what some of them were. Now understand that indeterminate is not an answer, okay? Indeterminate, those forms isn't an answer, but they do alert you to the fact that you may need to start over and solve the problem by a different method, as it says there on the bottom. So for example, if I evaluate here by plugging in infinity, I get infinity to the fourth over 1 over infinity squared. Well, infinity to the fourth is infinity. 1 over infinity squared is 0. Well, infinity over 0 is indeterminate, meaning you can't do it. Can't divide by 0. However, if I do this a different method, where I say, okay, n to the fourth times 1 over n squared, that would be, if I divide by a fraction, I multiply the reciprocal. Now I'm taking the limit as n approaches infinity of n to the sixth, which is infinity to the sixth, which is infinite, which means that the limit does not exist because of unbounded behavior. So now we came up with an answer that the limit doesn't exist, whereas before we couldn't determine what was happening. So for the next one, like 1 over infinity and 1 over infinity to the fifth, that's equal to 0 over 0, which is indeterminate. Can't divide by 0. But if we do some algebra, we get that it's n to the fourth, which is infinity to the fourth, which is infinite, which means it does not exist because of unbounded behavior. So here, 1 over n to the fifth over 1 over n, so 1 over infinity to the fifth over 1 over infinity, that's 0 over 0, which is indeterminate. But if we do the algebra, we get 1 over n to the fifth times n, so it's 1 over n to the fourth, which is 1 over infinity to the fourth, which is 0. So the limit here is 0, not infinite. N to the seventh over n to the fourth, that's infinity to the seventh over infinity to the fourth, which is infinity over infinity, which is indeterminate. But if we do here, it's n to the third. So if we find the limit of as it goes to infinity, that's infinity to the third, which is infinite, which means it does not exist because of unbounded behavior. So that's what happens if it's indeterminate. We can simplify to get a determinate answer. So let's look at another method. So notice we started out observing terms, then we plugged in infinity, then we used the limit theorems to multiply by 1 over n to the highest power to use the limit theorems to find the limit. Now, one thing you could have noticed from the limit theorems is that all the ones that weren't the same power as 1 over n to the highest power, the limits became 0, which means the only ones that matter are the ones that are the highest power of n. So the last method that we'll talk about is observing highest powers. And so if we're going to do it by observing highest powers, we're going to put OHP right here, which means that we take the highest power of n, the constant, the highest power of n, and then use the coefficients of those terms to identify the limit. So for example, highest power of n is n to the third, so it's negative 5 over 2, so it's negative 5 halves. And that's what we got on the same problem up above by doing the limit rules. So here, part B, the highest power of n is n to the third, so observing highest powers, we're going to get negative pi over negative 6, which is pi over 6. Here, the highest power of n is n to the fourth, so we do not have any n to the fourth in the numerator, and we have 2 in the denominator, so that's 0. Here, n to the third is the highest power of n, so we have 8 in the numerator, but then we do not have an n to the third in the denominator. So 8 over 0 is infinite, which means it does not exist because of unbounded behavior. Part E, if you notice, if you multiplied it out, we're going to observe highest powers. If you multiplied this out, you get 8n to the fifth, and then something, over 3n to the fifth, and then something. So basically, the highest power is n to the fifth, so it's 8/3 is the limit. Part F, so if you look here, part F, well, if we get a common denominator, the common denominator here would be n to the second so we could go 2n actually we'll look at it this way. If we were to FOIL, we would get 10 over n to the third plus 15 over n squared minus 8 over n minus 12. And then if we got a common denominator, it would be n to the third. So it would be 10, do it this way, limit as n approaches infinity, of 10 plus 15n minus 8n squared minus 12n to the third, all over n to the third. So by observing highest powers, we could get the highest power is n to the third, we get negative 12 over 1, which is negative 12. So that's what it means by observing highest powers. So now let's look at some problems here. So the first one we're going to do by plugging in infinity. So we would get the square root of infinity plus 5. Actually, we'll do it this way. Equals the limit as n approaches infinity of the square root of infinity plus 5 minus 3 over infinity minus 4, which equals infinity minus 3 over infinity minus 4, which is infinity over infinity, which is indeterminate. So plugging in infinities is indeterminate, but we can do some algebra here. To get rid of the square root, we can multiply by the conjugate. So we can multiply it by the conjugate of the numerator, so it's n plus 5, square root of n plus 5 plus 3, that we're going to multiply top and bottom. So we get the limit as n approaches infinity when we multiply of n plus 5 minus 9, because it's the difference of two squares, over n minus 4 times n, the square root of n plus 5 plus 3. Now when we simplify the numerator, we get the limit as n approaches infinity of n minus 4 over n minus 4 times the square root of n plus 5 plus 3. Notice the n minus 4's cancel out, so we get the limit as n approaches infinity of 1 over the square root of n plus 5 plus 3. So notice if we now substitute in infinity, so we get the square root of infinity plus 5 plus 3. So it's equal to 1 over infinity plus 3, which is 1 over infinity, which is 0. So the limit of this is actually 0. So next one, by substituting in infinity, we get 1 plus 1 over infinity to the infinity power. Well, remember, 1 over infinity sorry, I forgot to write the limit as n approaches infinity here. So 1 over infinity is 0. So it's 1 plus 0 to the infinity power equals 1 to the infinity, which is 1. Now by doing it by observing terms, if you substitute it in your calculator, you get 2, and then for bigger numbers you get like 2.613, and then you get 2.7183, and so this is basically going to go towards the number e, which is 2.718. So notice the difference you get by doing one technique over the other. All right, next one, by plugging in infinity, you get infinity minus infinity squared, which is infinity minus infinity, which is indeterminate. So n minus n squared, if you observe highest powers, notice you can say this is over 1. So it'd be negative 1 over 0, which goes towards negative infinity, which means the limit does not exist because of unbounded behavior. And if you notice, if you observe terms, you put it in your calculator, you would get 0, negative 2, negative 6, and then down the line, negative 110, negative 132. So notice it's getting smaller and smaller as the numbers get bigger and bigger for n. Notice this one we're coming back to that we did previously, that we put infinities in. So here it'd be infinity squared over infinity plus 1 minus infinity squared over infinity plus 2. And remember, we said that's infinity over infinity minus infinity over infinity, which means it's indeterminate. So another method that we could use would be to observe highest powers. right? So in order to do that, we want to make it one expression, which means I could take the limit as n approaches infinity of n squared times n plus 2 minus n squared times n plus 1 all over n plus 1 times n plus 2. Then I have to multiply it out. So I have n to the third plus 2n squared minus n squared minus n to the third minus n squared all over n squared plus 3n plus 2. So then it becomes, the n to the thirds cancel out. So it becomes 1n squared over n squared plus 3n plus 2. So if we observe highest powers, with the limit as n approaches infinity, that would be 1 over 1, which is 1. All right, next. So the limit of, as n approaches infinity, of 5 minus 7 over n, if we just do it with infinities, we get 5 minus 7 over infinity, which is 5 minus 0, which is 5. Now if we observe highest powers, the limit as n approaches infinity of, now we got to get a common denominator, so it would be 5n minus 7 over n. So then to observe highest powers, we would get 5 over 1, which is 5. So the limit in this case is the same if you plug in infinity or observe highest powers. So sometimes it's the same, sometimes the highest powers get you closer, or in some instances, observing terms get you closer to the actual answer. All right, so we'll continue next time with some more questions, but that was the fifth method, which is observing powers, observing highest powers. I'll see you guys in class. Have a good evening.